Okay, first question, describe the difference between active low dengan active high outputs. So, ini saya ada terangkan lah. So, active low means only the output that is active will become low while the other output is high. So, usually a logic circuit using a NAND gate is active low. So, the output of the circuit will what we call it, dia bergantung, bukan bergantung lah. It correspond to zero. Okay, kalau dia zero tu maksudnya dia adalah high. Dia bukan dia on lah. Zero dia on, one dia akan jadi off. So that is active low, where it is using NAND gate lah normally. Active high means only the output that is active will becomes high while the other output is low. Okay, so yang ini, this is a normal condition lah. And kita biasanya guna AND gate. Right? So, one will becomes on. Satu akan jadi high akan jadi satu. High itu satu. Then means that kalau ada LED, dia akan menyala lah satu. Okay, kalau kosong means dia tak menyala. So that is the other way around lah, between active low dengan active high. Alright, so ini dia punya penerangan lah. Okay. Alright, and then number 2, this is a multiplexer punya question lah, where you use a 41 marks to implement the logic function of these two. So ini example ada dekat dalam my notes, and dekat sini pun saya ada buat dia punya solution lah. So the first one, for function of A, B, C, equivalent of sum min term 0, 2, 4, 6. So kalau macam ni, so if the question is like this, using the small m, meaning that is for the min terms punya condition. Alright, so min term condition, we take it directly lah. So implement it on the table, the implementation table, A, B, C. So we have A bar and A for zeros and 1. Okay, this is the input. BC will become the selector. So you have the input 0, input 1, input 2, input 3. Where input 0 is for 0, 0. Input 1 is for 0, 1. Input 2, 1, 0. Input 3, 1, 1. So 0, 1, 2, 3, 4, 5, 6, 7. How do you get this number? By reading the binary number lah. 0, 0, 0, it is 0. 0, 0, 1, it is 1. 0, 1, 0, 2, 0, 1, 1, 3, and then 1, 1, 0, 4, then the rest sampai 1, 1, 1 lah, 7. And then the rest, the next step is to round up the numbers which are listed in this bracket lah, dalam parenthesis ni, which is 0, 2, 4, 6. So I round up 0, 2, 4 and 6. And then kita buat dia punya comparison between input of A bar and A. Right, so if both of the rows are round up, each of the rows lah, maksudnya kedua-dua row ni dia bulatkan, then the input will becomes 1. Macam ni tak ada, so it will become 0. And this one, they are both of the rows are round, so 1 as well. This one, they are no round at all, then dia akan jadi 0. Okay, so 1, 0, 1, 0. So how to implement them? You draw a 4 to 1 marks, because the question is a 4 to 1 marks. And then replace the input of each of the I0 until I3 with this, with the one that you obtain here. Okay, so I0 is 1. I1 is 0, I2 is 1, I3 is 0. So 1, 0, 1, 0. Selector is B and C. And then the output is F. Okay, so this is the block diagram, and then this is the circuit diagram. So that is how you implement Boolean expression using multiplexer. Okay, we look into the second one for the function of x, y, and z. Alright, so which is equivalent to sum of, okay, ini dia sekejap ya. Ada sedikit typo di situ. Okay, this is supposed to be capital M lah sebab dia max term. Itu beza dia lah, max term dengan min term. Alright, and then I'll add up capital M. So this is supposed to be capital M lah. Alright, sum of max term 0135 kan soalan dia. Sum of max term, oh ini pun sama, patutlah salah. Oh. Silap. Ya. Okay, sum of max term and then sum of min term. So dia huruf dia memang kena beza lah. Okay, and then satu lagi sini dia pakai Y dengan Z. Okay, kejap ya. Saya tersilap typo ni. Then here as well, this should be this is X 0 and So this should be x, this is 0, this is 1, and this is x. Alright, and then last one, here pun sama, this is x, and then this is x, and x. So, ubah dia punya variable tapi saya lupa nak buat dalam solution. Okay. Alright, so ini baru betul lah. So implementation of 4 to 1 marks for this Boolean expression where the sum of max term 0135 is basically equivalent to the sum of min term. Okay, kita nak jadikan dia sama macam yang atas ni. Alright. Itu min term ni is the one which are inverted from the max term lah. Kalau dekat sini 0135 means that min term dia adalah 2467. Sebab apa sampai 7 saja? The reason is because we only have 3 bits x, y and z. So 000 up until 111 means that 0 sampai 7 sahajalah, 0 until 7. Sebab tu hanya ada list 0 until 7 here. Okay, 0, 1, 2, 3, 4, 5, 6, 7. So now kita bulatkan number which are listed in this parenthesis, dalam inilah, dalam kurungan. Itu 2, 4, 6, 7. So 2, 4, 6 and 7. And then compare, ini pun sama. Ada lagi rupanya. So, this should be x, y, z. And then, this is basically needs to become x lah. This is x and then y, z. Replacing the a, b, c. And then this is x bar for 0. And then this is x for 1. Okay, so compare the two rows. This one only round up at x, so dia jadi x. This one has no round at all, so it is 0. This one both are round up, so it will become 1. This one at x as well, so it becomes x. Alright, then replace x0, 1x for I0, I1, I2, I3, so x0, 1x. And then select output, select input is y and z, so put y and z there. Same goes to the circuit diagram. X0, 1x and then y and z. Output is f ke? After output is still f, so okay, betul lah tu. Okay, so nanti saya share solution ni dengan you all. Alright, so this is the 2 steps on how to implement Boolean expression using 4 to 1 marks. Okay, so meaning apa yang akan jadi sini kita tengok kat sini lah. Example ni ya. Second one, when Y and Z is 0, 0, okay, when this is 0, 0, output F will becomes X. Kalau 0, 1, dia akan jadi kosong. 1, 0, F will becomes 1. 1, 1, F will becomes X. Okay, so that is how I read them from this table. Okay, 0, 0, X, 0, 1, 0, 1, 0, 1, 1, 1, X. So, itulah cara nak implement Boolean expression by the usage of 4 to 1 marks. Kita boleh guna 8 to 1 marks pun boleh, 2 to 1 marks pun boleh. Okay, so they are utilizing the same steps, same concept. It's just that dia punya implementation table ni berbeza sedikit lah. Kalau 8 to 1 marks, so you akan ada 4 variables A, B, C, D ataupun P, Q, R, S, okay, W, X, Y, Z. So table dia akan jadi sedikit besar lah. Okay, so that is number 2. Number 3, design a 16 to 1 marks by using 4 to 1 marks. So yang ini you can find them easily dekat dalam internet lah. Okay, so you use 5 units of 4 to 1 marks. Okay, then you connect them 4 in series with 4 in parallel with 1 in series. Okay, 4 ni secara selari dan output dia kenakan kepada secara sesiri kepada another 4 to 1 marks. So we have here the first 4 to 1 marks will be the first 4 inputs I0, I3, second one I4, I7, third one I8, I11, fourth one I12, I15. Okay, so dekat sini kita ada 16 input lah, 16 to 1 marks. And then kita kena make sure each of the output of these 4 parallel 4 to 1 marks to be the input of the series 4 to 1 marks. Okay, so ini input marks yang pertama, ini yang kedua, ini yang ketiga, ini yang keempat. Then you have the output for the whole marks. Okay, for the 16 to 1 marks. Okay, now kita kena analyze pula dia punya selector. Yang ini kita ada 2, ada 4, ni ada 6, ni ada 8, ada 10 selector. Where we know for a 16 to 1 marks, you only have 4 selector. Okay, 16 punca kuasa 2 adalah 4. So sepatutnya kita hanya ada 2 selector. 4 selectors. So if you look at the name of each selectors, these 4 4 to 1 marks are having the same name as S0, S1, S0, S1, S0, S1, S0, S1. So meaning that the selector for these 4 to 1 marks came from the same source. Datang daripada sumber yang sama. So dia akan ada 2 selector S0, S1 untuk these 4 multiplexer. And then yang ini dia ada S2, S3. So lagi 2 selector ni hanya masuk dekat sini sahaja. Okay, so this selector, let's say it is 0, 0. When it is 0, 0, maksudnya I0 akan jadi output, I4 akan jadi output, I8 will becomes the output, I13 will also becomes the output. So you akan dapat dekat sini I0, I4, I8, I13. But which one will becomes the output of the whole 16 to 1 marks will be determined by this selector pula. Let's say 0, 0, 0, 0. So dia akan jadi I0, I4, I8, I13 masuk kat sini. Dekat sini pun 0, 0. So dekat sini 0, 0. And then here also 0, 0. Which is 0 lah. 0, 0, 0, 0. Then I0 yang dapat masuk first ni yang akan keluar dekat sini. If it is 0, 0, 1, 1. Say, okay, 0, 0 for this 4. Still I0, I4, I8 and I12 yang akan masuk sini. Right? And then 1, 1 dekat sini, we know 1, 1 yang akan jadi output is the last input. I0, I1, itu I3 lah. So I3 tadi adalah I12. So dekat sini kita akan dapat I12. Okay, so by this way, you can design a 16 to 1 marks by using 4 to 1 marks. Okay, so you can design larger inputs of multiplexers from a lower input of multiplexers. 2 to 1 to become 4 to 1, 4 to 1 to become 8 to 1, 4 to 1 to become 16 to 1, 8 to 1 to become 16 to 1, semua boleh. Okay. So that is actually a good information for us lah, in case if we don't have the larger number components, but we have the lower number components, but we can combine them to make sure that you can use the larger components as well. Okay, sama juga dengan decoder. Last week kita boleh combine 2 to 4 decoder untuk jadi 3 to 8 ataupun nak jadi 4 to 16. So it's the same way lah. Okay, so basically they are bukan juga multifunction lah. They are expandable within themselves. Okay, kita boleh extendkan dia dengan menggunakan benda yang sama. Okay. Right, and then number 4, okay, last question. Design a parity checker circuit using 4 to 1 marks where the circuit accepts 3 bits binary input and it will generate high output every time odd number of ones detected. Okay, so dia punya keyword dekat sini adalah odd number of ones. Maksudnya input dia punya satu adalah nombor ganjil. Okay, so kita buat dia punya table. Ini pun dah ada dalam note saya, so you may refer to the solution as well. Kalau you tak faham, please let me know. Okay, it has 3 inputs, so I name them as A, B and C. A is the input, B and C will become the selector. So we represent the ABC in binary from 0 until 7, so 0, 0, 0, 0, 0, 1 up until 1, 1, 1. Right? And then we calculate the number of ones which are listed in each rows. Kalau jumlah dia genap, dia akan jadi 1. Kalau jumlah dia ganjil, dia akan jadi kosong. So 0, 0, 0, there is no ones, so dia becomes 0. 0, 0, 1, there is 1, 1, so dia ganjil, so dia akan jadi high lah. So number dia adalah 1. And then 0, 1, 0, you have 1 ones as well, so it is ganjil, odd numbers, so dia akan jadi high, iaitu nombor 2. 0, 1, 0 is number 2. 0, 1, 1, you have 2 ones, so it is genap, so dia akan jadi kosong. 1, 0, 0 adalah ganjil, so high, then the number is 4 lah. 1, 0, 0. 1, 0, 1 adalah 5, ada 2, which is 5, tapi dia ada 2, so 0. 6 also 2, 0. 7 ada 3, it is odd number, so sini akan jadi high. So the numbers included is 1, 2, 4, 7. So use the implementation table. Round the numbers which is high, 1, 2, 4 and 7, and then compare between rows A and B, A bar and A. So this one is round up at A, this one is at A bar, this one is at A bar, this one is A. So you just replace I0 and until I3 with this variable, draw it into the diagram. So you will get A bar, A for the input, and then the selector is B and C. Same goes to the circuit diagram. A bar, A, B, C, the output is F. Okay, so if you look into this solution, sebenarnya sama je solution macam ni. Okay, cuma yang ini soalan dia bagi dalam bentuk equation terus. Okay, number 2, dia bagi terus dalam bentuk equation. This one, you kena analyze parity checker ni, apa dia punya condition, berapa inputs, and then how the output will be generated high. Macam ni, dia bagi odd number is 1 detected. Dalam my notes kalau tak silap, dia dalam dia nak kalau jumlah 1 dia adalah genap kalau tak silap. Saya pun tak ingat. Right? So steps dia berbeza sikit lah. You have to elaborate the table first, then baru you boleh dapat dia punya implementation table. Okay. So that is the solution. Sekejap lagi saya share dekat dalam group WhatsApp.